All right, hey guys, I'm back. So we are on slide 15 and 22. All of these words here basically talk about the complement of an event. The complement of an event is basically means the opposite of it, that not happening. And they use this weird notation with like little squigglies. So if you see P of squiggle E, that means not E. And it is all of the times that that event doesn't happen. So the way we figure that out is we do 1, because that's the total probability is 1 minus the event happening, and that will give us the probability of the event not happening. Okay, so if we go into this next one, those are again complementary events. Here what we're doing is we're rolling 1 6-sided die and then tossing a fair coin. That just means it's heads or tails. Either one is just as likely as the other. We want to find the total number of possible outcomes for this. So some possible outcomes would be like rolling a 1 and then getting a heads. You could roll a 1 and then get a tails. You could roll a 2 and get a heads. You could roll a 2 and get a tails, so on and so forth. So basically for the roll, there are 6 possibilities. And then for the coin toss, there are 2 possibilities. So 6 times 2 gives you 12, which is our total possible outcomes. So that's the total number of outcomes we can have. Find the probability of the result is not 6 heads. So the first thing, so the event is 6 and then heads. So let's just find that probability first. And there's only one way to roll a 6 and then get a head, so that probability, so P of E is 1 divided by 12. Put a sign in there. Okay. And then, so if I want P of not E, what I'm going to do is I'm going to do 1 minus 1/12, which will give me 11/12. So another way to think about it is every 12 ways, there's one way to get 6 and a heads. That means then there's 11 ways to not get that. Okay, so this is our answer, 11 over 12. Yeah, we got it. Okay. Find the probability that tails and an even number do not occur together. Okay. So if you ever get stuck, what you could do is you could always just list out all the possibilities, but you don't have to. So I don't want tails and an even number. So what I'm going to do is I'm going to find all the ways that I can get tails and an even number. So I could do 2 tails, I could get 4 tails, and then I could get, go back, 6 tails. Okay, these are all the ways that you can get an even and a tail. Okay, so that probability there's 3 ways that you can do that. Now what that means that if I don't want that, like I don't want any of these options because these have tails and an even number together, there's 12 total ways. So that means in order for it to not happen, I'm going to have 9 out of 12 total possibilities, which would reduce to 3 over 4. Okay. If you look down here, they did a little bit differently. They found that probability, which was 1/4, and then did 1 minus 1/4. But hey, it doesn't matter. We got the same answer. Okay. But it's easiest to find the number of ways that it does happen, and then you can figure out the number of ways that it doesn't happen. Number 4, find the probability that the outcome is neither 2 heads or 3 tails. Now they've given you 2 possibilities here. Okay. Now the probability of either one of those occurring is 2 out of 12, 2 out of the total 12 possibilities. That means there are 10 out of 12 ways for it to not happen, which again, we want to reduce that, which would be 5 out of 6 for a probability. That's what we got there. Okay. So to find how, whenever they talk about something not happening, just find the probability that it does happen and then subtract that. Find the probability that the outcome is either tails with any number or heads with any number greater than 1. So let's just start with, this is a little different because it's or. So if anything, tails with any number. Well, there are 6 ways that can happen. Right? You get 1 in tails, 2 in tails, 3 in tails, so on and so forth. Or you could get heads with any number greater than 1. Well, any number greater than 1, well, that basically is everything except 1, right? So there's 6 ways that you could get heads with any number, but if I just exclude the 1, that means there's 5 ways there. Okay, so for either one of these to happen, altogether I have 11 ways. Because really the only thing that's excluded is 1 and heads. That's the only thing that's excluded. And that's where we get that probability of 11 over 12. Self-evaluation, again, we did an awesome job. Okay? And then this next section, again, all of this stuff looks super complex and everything, but what this is happening is we have 2 separate events. These are what we call mutually exclusive events, or if, yeah, so here we have mutually exclusive events. Sorry, I was getting ahead of myself. They have no common outcomes, like they cannot both happen. Okay, and if you have 2 things that cannot both happen, like on that last slide, that very last problem we did, these are mutually exclusive. Okay, because you can either get tails or you can get head. Both of those cannot occur. Okay, and so to find those probabilities, you do exactly what we did. If you see a U there, that means we're going to join these 2 sample spaces, and you would add the probabilities. Okay, now if you have events that do have some overlap, then those are what we call non-exclusive events. They are not mutually exclusive, so they could both occur. So what you would do is you would add the 2 probabilities, but then you have to subtract where they overlap. Okay, because if you just added the 2 probabilities, you'd be double counting everything in here. Okay, so that's what those 2 slides with lots and lots of words say. So this all looks kind of crazy here, but what we're doing is the probability of drawing a card that is either a club or a queen. Okay, I'm not going to use this notation, but I'm going to come over here. So I want to know the probability of getting a club or a queen. Now, are these events mutually exclusive? No, they are not, because you could have something that is a club and a queen. So to figure out that probability, we're going to figure out the number of ways you can get a club. And if you remember, there are 13 cards in each suit, so there are 13 ways that you can get a club. For a queen, there are 4 ways that you can get a queen, because there's the queen of clubs, queen of hearts, queen of spades, queen of diamonds. Okay. Now to get the probability of pulling a club or a queen, I cannot just add 13 and 14 and say that that's the number of ways divided by 52, because the queen of clubs, the wrong one, not my best work. The queen of clubs would be counted twice. It's in here and it's in here. Okay, now that's the only place that they overlap. So to figure out the total number, to figure out the sample space, you would have to do 13 plus 4 minus 1. Okay, so 13 plus 4 is 17 minus 1. So this means there are 16 ways that this could happen. Okay, so to get the probability, there's 16 ways you can get a club or a queen. There's 52 total cards. So that's the probability. We always want to reduce it, which would give me 4 over 13. Okay, which, oh, hey, that's what they got, but hopefully my way is makes a little more sense than all of that stuff there. Non-exclusive events. Let's keep doing a couple more of these. Here we have standard deck of cards. We are going to find the probability of getting a black and a numbered card. Okay, black and numbered. So first of all, for a black card, remember that black suits are the club and the spades. So 2 of the suits are black, 2 of them are red. So that means half of the 52 cards, so 26 cards, are black. But for the numbered cards, the numbers go from 2 through 10. So if you count on your fingers, 2, 3, 4, 5, 6, 7, 8, 9, 10, you'll find there's actually 9 numbered cards per suit. There's 4 suits. So 9 times 4 is 36 cards. Okay. Now, I cannot just add those up. Well, it said they want us to find the probability of each separately, sorry. So, let's go back. So for blue, the probability of black would be 26 over 52, should be 1/2. And the probability of numbered would be 36 over 52, which I'm on practice, sorry. Okay. 9 out of 13. Okay. So those are the individual probabilities, which is what they ask us to do. P of E1, that's probability that it's black, the probability that it is even. I'm sorry, that it is numbered. So find the number of sample outcomes that are common to the events. So which of these cards are black and numbered? Okay, so again, if you want, you could sit there and count through all of them. I would not suggest that though, but you just know that, okay, there's 36 numbered cards. Half of them are black, half of them are red. So there are 18 cards. So half of the numbered cards also be black. So 18 cards are numbered and black. Okay, or you could do it the other way and say, hey, there's 9 numbereds in each suit. So that means if there's 2 suits of black, you're going to have, again, 18 cards that are numbered and black. Oh, we didn't submit them. Let's make sure we're right. 9 out of 13. Yay. And then here, 18. Okay. Find the probability of the intersection of these two events. So the intersection is this right here. There are 18 cards that are both. So it'd be 18 divided by 52, which is 9 out of 26. Okay. Find the probability that a card drawn is numbered or. Okay, so up here, when it's the intersection, they basically want to know the probability that it is numbered and black. This next question is asking or. So what I would do is I would try to find the number of cards that would be numbered or black. Now we said that numbered, there were 36 cards, and black there were 26. So it would be 36 plus 26. However, first of all, if you add those up, you get more than 52. There's only 52 cards in a deck. Remember, if it's an or statement, you want to overlap. I'm sorry, if they have events that double up, you want to subtract them. So if I do 36 plus 26 minus 18, that gives me 44. So the probability of that would be 44 divided by 52, 11 over 13, which is what we got down here. Okay, so now we have to find the probability the card is not a numbered card. So again, if we said that there were 36 numbered cards, 52 minus 36, when you do 52 minus 36, you get 16 cards. So that are 16 cards that are not numbered. So 16 divided by 52 gives you 4 over 13. That's the probability of getting not a numbered card. Okay, so what is the sample? Now for this next one, what's the sample space when you draw one card twice instead of 4 kings? The card is replaced. So on that first draw, you have 4 possibilities. On that second draw, you also have 4 possibilities. So the sample space is going to be 4 times 4, which is 16. So there's 16 possible outcomes there. Number 7 and 8, I'm not going to worry too much because these have to do with those casino things. And so we're just going to kind of skip over those self-evaluation. We got a 5. And then now. So now we have just the summary page. Okay, so don't let this notation bog you down. P of E is just the probability of something happening. N of E, that's the number of ways that it could happen. So the number of ways you could roll an even number, or the number of ways you could pull a red card. So that's N of E. N of S is just the total number of possibilities. Like in a deck of cards, it's 52. If you roll in 2 dice, it's 36. Okay, this notation there, that means not E. So you just find, so that would be like the probability that something is not a 7. Okay. And then now this next slide says, yay, we did it. Okay, so hopefully me walking you through that makes it a little bit easier. I'm going to try to do that for the rest of these. And hopefully I will be able to. Okay, so sorry. Okay, so I'm all done. If you have any questions, let me know. You guys should hopefully be able to attempt that mastery test. I'll give it your best shot. And that's all I'm asking for you, is that you give me your best effort. I don't expect you guys to all ace it. But I hope you're doing well, and let me know if I can do anything for you.